Hello, part 2, we're starting. Let me check. Let me stop that. Okay, okay, so let's continue. So now I will try to show you more practical examples. Oh, you see, some people are watching us. See, it's 2 already, huh? So I'll show you some more practical examples, and I will. Let me check. I need to share my screen, I guess, like that. Oops. Okay, so I prepared 2 places, which are funny at least. Bless you. Let's start this one. Calendar, create calendar. First, we'll start with something simple, and then more and more complex. Calendar, create calendar. Let me find it. It's a huge class. Create. Here you go. And what I wanted to show them. Yeah, this one. So, so what they're trying to do here, they are creating a provider. They're trying to find the provider for the calendar. And then if the provider is not found, they're trying to get some other provider. And if something goes wrong, they're saying we fall back to the default instantiation. So this is what is called flow control by exception. So if the provider is found, return immediately. If the provider is not found, they continue. So basically, it has to be if then else. But instead of having if then else, they use exception. So how would you change that? So all my questions now, how would you change that? How would you improve that? So let's stop trashing them and saying this is all bad, but let's suggest some solutions. No. Here, look. So first we try to find the provider. Okay, the provider is not null. If it's not null, then yeah. So the bottom line is that we need a calendar. So we can get that calendar from the provider, or we can get that calendar somehow this way. So that's what I think is happening. But I'm talking about that part of the code. So here I think, why can't I edit it? What's wrong? Do you know? Let me check. I think it's here. I don't know.
This part again, but choose in the list Java file.
Java file. I was editing something today.
And calendar.
Yeah.
And
down here.
Yes.
What's the difference? Yeah,
yes.
real. Why?
Previous file was from OpenJDK.
Ah.
Is this one from?
I got it. Okay. Okay, so create calendar. That's the code. So here, I think the right approach would be this one. We should say, actually, this is what has to be done. If provider has instance. Else, this one. That will be the right code. So what they are doing, it's exactly what I just did. So we are checking if the provider exists, then we return the provider. Otherwise, we fall back. Actually, this code is also wrong. It should be like that. This is the right code. If the provider exists, then we get it, and then we return. Now they're trying to do the same using the exception. So exception is telling them what's the next step. Because we don't know, we're making an assumption of what will happen inside get instance. So this illegal argument exception maybe will jump out because the provider is not found. Maybe not, maybe something else will happen. And we're gonna just lose the stack trace. That's exactly what I said before. So it's not fail fast, we're gonna lose this information. So that's the right code. So instead of using exception for flow control, we have explicit flow control. But some people may say that, look, this is too expensive because once you check, then you get on it. So you're gonna make 2 round trips. So you will go there, check the instance. It's there. Okay, then I go again, get me the instance. Here they will say, okay, it's faster because in most cases there will be no exceptions. I will just get instance. It will come back and I will return. So they may say that this code will happen just sometimes, very, 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 very sometimes. So in most cases, that's true, maybe. But in this case, how do you avoid that? How do you fix that problem? You don't know, I'll tell you. So you do this. We're in Java 7. You do this. Provider, and then not the provider, with the calendar. Do provider to get instance something. And then you say if calendar, I don't know, is empty or whatever, or has or what? That's correct? Okay. And then I do get. In that case, we have just one round trip, right? We just go to the provider only once. Now that's correct. And it returns the calendar or an empty optional. If it's empty, we continue. If it's not empty, we just return. So that would be more or less object-oriented design. This is just wrong on so many levels. Agree? Make sense? So don't do that. I mean, if you see that code in your case, just don't do that. Another example, I have many. Abstract collection contains. Abstract collection. Abstract collection. This one, right? Yeah, contains. Yeah, that's beautiful. So, and it's everywhere. So look, contains, they have this if it's null. So they're actually checking for null. So if null is coming, so they are allowing this abstract collection is allowing us to have null inside the collection. Which is, I mean, I think it's wrong in general. I would not do that. I will just prohibit using null. But some people, for some reason, may have null inside the collection. So now I'm asking the collection, do you have an object? Does it contain null, for example? So first of all, it checks, is it null? And then it goes with this code. Then it says, else if it's not null, it goes with almost exactly the same code. So this line is the only line which is different. So they look exactly the same way, but here they compare with null. Here they compare using equals. I don't know whether, first of all, I think I would refactor it because it happens everywhere. Look at this code. Look at this one. Exactly the same. Look at, no, well, not exactly, but really close. So remove contains, add is different. Yes, removing contains, okay. But I would do it differently. I think it would be correct, first of all, to move, to say the opposite and say like this. And remove that trash. So now the check for null or not null will happen inside equals. Right? It's only logical. So just change the way you compare. So they were
if collection contains null, here will be no further exception. Yes.
You need a option.
You can say null.
Why? The next will return exception?
Because collection contains null.
Ah, okay. So we're checking for null inside the collection. Ah, okay.
Yes.
Yeah, but it will do the same. But the same will happen here. Wait a second. The null. Ah, okay.
We don't
Oh, I got it.
all equals or not.
I got it. Okay. No problem. I agree with that. What I don't like is this line.
You could expand if expression. Something like.
You mean put the if? I can make it more complex. Yeah.
Or.
Exactly. Yeah. Because it looks kind of weird for me. So two loops, two loops, which look very close to each other. I think it would be better to make this if statement longer, and that's it. To check for null there.
I think go through all elements or contains is really very expensive.
Could be. What do you think about this line? So how can it throw a null pointer exception? I tried to understand. I don't think it's possible at all. Which one? Here?
Yeah.
No, we check for null. Look. So this call is not going to be null. Yeah, but inside, okay, come on. What? This one?
Yeah. Custom collection and
Yeah, but do we need to declare that here? I mean, in that case, I have to put this on all methods everywhere, right? You can say like everywhere. So they are saying that null pointer exception may happen right here, not in the methods somewhere else, but right here. So I think it's just a typo. So I think it's just wrong. It may not happen here.
and it is from here it goes.
Yeah, it's from here, right? That's what they're saying, probably.
But in here usually is from parent class.
You mean this one? So it's just inherited from.
But
Okay, let's take a look.
I didn't see a correct notation.
Let's check the collection. Contains, right? Null pointer exception if the specified element is null and this collection does not permit null elements. So it may throw null only if the element is null and this collection doesn't permit. Our collection does permit, right? Because it allows us to have null. So this line is wrong, right? So it's just a mistake in OpenJDK.
What about iterator? It is on,
Iterator?
Java for iteration.
Here. Okay. Just returns an iterator. That's all.
There is no nullable or non-null notation.
No. Could be anything, but
it can be null.
can be null. Yeah, it can be null. Yeah.
And we can get to null.
Well, yeah. So in this case, I will annotate all my methods. Like, yeah, I may throw null pointer exception everywhere. Who knows? Anyway, it's not a big deal, but I just wanted to show you. Another one which is interesting. It's a different discussion. I'll show you now. We didn't talk about that yet. Let's see the method sort. Erase, sort. Yeah. Look at what's happening. Maybe it's not a perfect example, but this is what is called temporal coupling, more or less. So this line, what they're doing is that if you go to range check, you know what sort is doing, right? Arrays.sort. So you provide an array and it sorts the array. And then there are two calls. The first one is called range check. The second one, dual something whatever dot sort. So there are two lines, two calls to two procedures. Let's see what range check is doing. Range check. So range check is basically accepting three numbers and just compare who is, if the from index is more than 2 index, throw an exception. If this index is less than 0, throw an exception. If blah, 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 throw an exception. So it's pretty innocent, it's called like range check for the data which is coming in. My problem here is that these two lines are so-called temporally coupled. So they must stay together, and they must go in that particular order. So you cannot change the order of them without breaking the logic. But it's not clear for me as a programmer who is touching this code later, because in this case it's more or less clear, but if there would be some code here, something, I don't know, then the logic that this line must go before this one is just, it's kind of implied. I mean, it's not explicit, it's not written here. It's just, I have to understand that the range check logically have to go before the sort. So I cannot just replace, I cannot swap them. And this is bad for maintainability. So that information is making the code less maintainable because it's difficult to change. I always need to pay attention to who goes first, who goes last. I'll show you maybe a little bit longer code to demonstrate what I mean. Maybe not in this class. Yeah, maybe I can't. Maybe I'll show you later. But here again, look, the range check here, and then this one, and then that one. So they go one by one. And in general, when lines go one by one without any connection between them, they are coupled, but we don't know how. So we don't know what's. Can we actually move it here, for example, like that, without breaking the logic of the code? So do we need this range before this line as well, or maybe not? Does it have to stay on top, or maybe not? So they're not connected anyhow. Would be a better approach to do is if we do it like that. So, and the problem here is that they're all procedures. So this is procedure which is returning void. Yeah, it returns void. It just accepts something and returns void. And this one also does something and returns nothing. So it would be way better to redesign this range check and put it here. And make it return something which will be acceptable for this line. See the logic? Because when you have just one line and say, do this, and then do that, and then do that, they're not anyhow connected. And then the code is not clear for me as a reader that they actually have to go, that they actually depend on each other. So now I absolutely know that this line need an array which was range checked. I cannot, hey, how about I take it and put it here? That would be weird. Because it's clear for me that it has to be provided, that the input parameter for that function, for that method, has to be provided by that method. So they are related to each other. Because when they just stay one after another, there is relation between them is not clear. It's just in my mind when I write the code. And I say, check the range, sort the array, check something else, print it, log it. This is like flat line goes like that. And this is wrong. It has to be always like that. You have to try to indent it all the time. Because when you indent your code, it becomes solid. You cannot break it. You cannot just swap the lines the way you want. Because this code is not easily breakable. Because I cannot take the range check out of it and not break the logic. It stays together. When the code goes like this is a clear sign of procedural programming. That we are doing something wrong. Look. Yeah, this one. This is really bad code. One line, another line, another line, another line. It has to be, each call of the method or each creation object has to be needed by somebody. So you shouldn't just range check for fun. You have to do it for somebody. When you do it for somebody, then your result have to be required by somebody. So give it here. Even if you don't need it, so look at the method range check. If you look at this code here, if we go to range check, now it's not going to compile. Now it will not compile because the sort expects here probably the array of characters. And the range check returns something else. So maybe that code will not work, but we can do, okay, let's leave A here, but let's say we provide from index. Okay, instead of from index, we do it like that. And now the range check will return from index. Not static void, but the from index. So we make it instead of, now it's not a procedure, now it's a function which is injected, which is pluggable into a more complex call. And now our call here becomes way more maintainable because we clearly see where it is. It's here. Now we clearly see that I cannot sort without checking the range. I need to change. I need to range check first. Do I make any sense? Does it sound like something? Uncle Bob said that. There you go.
It's one of functional dependency.
Temporal
Functional dependency.
functional dependency. Okay. Well, I read about it as temporal coupling. That's what they call temporal coupling, meaning that we know that this line goes before and that line goes after, but it's not in the code. So we just understand it. We just know that range check is logical to do before sorting. But this connection, they're connected temporarily. I mean, they're connected in time. So that one goes before, that one goes after. But it's not in the code. The code doesn't say it. So if there are just 2 lines, it's okay. We can understand. But if it's in a few years, there's going to be 15 lines. We're going to lose that information. We will not understand which one goes first. And we will just say, I don't touch that method. I don't know how it works. I'm afraid to touch it because if I change the order of some lines, if I remove some of them and put them later or something, it's going to fail. Everything breaks. And I don't know why, because there's some connection in time. This one is not so easy to break because they're connected. File fast. Yeah, this one is also fail fast. This one will fail.
Move this range check to a base sort method, for example.
That's also true. Of course, we can move this range check into the sort method. Yes, of course. Yeah, most probably. Yeah, but here's the main point is that we need to connect functions to functions, not just if you see the flat line of functions, something is wrong. That's for sure. So you're not doing object-oriented programming. If your calls are go one by one and you have a straight line on the left. If you have that code like this, you're doing something really wrong. The line is flat here. Then you need to break it into different functions, just into new objects. But that's wrong. Should be never a flat line. Ideally, it should be like this. You've seen that, right? Yeah, that's the ideal. Or maybe it's a little bit too extreme, but it has to be like this is unbreakable. I cannot take this line and move it up. No way. It's the whole thing is one solid big piece of one solid object. Quite big. Okay, let's go to the next one.
I can propose another approach.
Yeah.
For example, as you can see, there are from index and to index and the range variable, but we don't see any range class.
Yeah.
For example, maybe we can create a range class which would have from index to index and this class from validation. So some sort of function will
accept that class. Yeah, definitely. That would be, of course, that's a good idea. Of course, if we really want to go object-oriented, we should have to get rid of just these functions, these procedures. We need to introduce a new object, which will be called range. And then that range will encapsulate from to whatever, and then this sort method will accept the range, of course, definitely. Because now look, we're just calling from, and then we're providing from and to index. So definitely these 2 numbers, 2 integers, we need to encapsulate into the range, and that range will definitely would be validatable, and it will say it cannot start from 5 and end to 3. It has to be the other way around. It has to be 3 to 5, and that's it. So that's the point, right? So this range, because now this is also procedural because we have just numbers. This is the length, this is from, and this is to. This information has to be in some object, in some class, and then in an object, of course, and then the whole thing will be solved. But these guys are using a really procedural approach. This is a really good comment. I agree. Second, common driver. Yeah. Okay, next one is called calendar get. Let's see what it is. Calendar says it has to be a file here, right? Yeah. Calendar get. Yeah. The same, even worse. It's the same example. So look what they have. So I'm calling get. And if the get is not here, I mean, there's something is unprepared in an object. Then they call function, method, procedure complete, and complete prepares the object for completing the operation. So it does some update time or whatever. So that's also very, very procedural, unclear approach. The same problem. So it shouldn't be like that. It's not clear for me in this code that complete will actually somehow affect the behavior here. So I don't know whether I need to complete before this internal get, or I don't need to complete. If I change something in the code, complete, will it affect this one? So it would be way better to do it. Would be way better to do it something like that. Completed like that. So first you complete and then you get. If you want them to go one by one, then you do it like that. So don't put them in the vertical, in the vertical line. They have to be wrapped one into another. Completed, get it, whatever. Yeah, let me change it back. Another example is, yeah, we've seen that. Yeah, this one, that's fine. Buffered input stream read. Buffered input stream read. Here you go. Yeah, here. So look at this code. This is a very typical mistake. It's not about really object-oriented programming, but I want to say it anyway. So look at this 4 lines of code. People are doing it quite often, and I really don't know. Maybe you can explain me why. But I don't understand why this code has to be like that if it can be like that. So what's the point of saying else here? There can be no else. You throw an exception. If this happens, then you throw an exception. So why saying else?
After completion, I think this line is cut.
So else is removed anyway, right?
Yes, in bytecode.
Yeah, but in bytecode, yes. So why saying it like that? It's just making the code more confusing. So it just confuses the reader. Because when I look at the else, I understand so when I have an article about that, let me show you, which has the diagram: if, then, else. Yeah, here you go. That's how I understand if, then, else. So if I go on the left line, else I go on another line. But we both end up in the same line. So if you go left, else you go right, but we continue the direction if we have if, then, else. This is what I have in if the code looks like this, but this is okay. Look, if, then, else. And now look at this line, look at this sign. This is impossible to imagine because there's a stop over here. I'm not going to go after. So this sign doesn't make any sense. I can go only left, or I'm going to stop on the right. So it has to be like that. So this is the proper sign. This one just doesn't make any sense to me. If I have if, then, else, it means that the sign in front of me looks like this. So when I look at this code, it looks to me like that. So if you go left, we're going to throw an exception. If you go right, we're going to return 0. But in both cases, we're going to continue. We're not going to continue. We're not going to continue after that, and we're not going to continue after that. So we're going to stop in both cases. It has to be like that. If this, we stop. If that, we stop. And then we continue. If, then, else gives me the wrong information. It gives me like this. It gives me the sign of that image, which is weird. In that case, if throw, then return, then this stop and this roadblock sign has to be on both sides. If you go left, it's going to be the end of the road. If you go right, it's going to be the end of the road too. And then you continue. This is how the code should look, I believe. If something's thrown exception, but then you don't say else. Some people told me that, we discussed that in one conference, and somebody said that maybe this is in order to show the programmer that this condition will be checked only if this condition is not passed. So it's more like a connection which will prevent us from doing this. So if you put like that, then somebody tomorrow may go like that, may swap them. Because somebody will say, okay, anyway, it's just a validation, one validation, another validation. How about I change that? Maybe that's the reason. But aside from that reason, I don't understand why people are doing this else here. For me, it just looks like people don't understand the logic of if then else. So I would recommend to, and there are many places in OpenJDK where code like that exists, like many. I'll show you. We'll see it more. So it's not about object-oriented, but still something. Let's check this one, input stream read. Let's check a big one now. Yeah, this one big, and it's interesting. Let's go to the class QRI. Yeah, it's a huge class with 3,500 lines of code. Here, I think we have a design issue, not this coding exceptions throwing, but really a design issue. Look at what's happening in their constructor. So when I create an object of class URI, then look what's happening inside the constructor. They create a new class called parser. The parser is an internal class. Here it is. It's also quite big. So the parser has access to attributes, to private attributes of the URI. And parser parses the text provided and injects the data into the attributes of the URI. See how it's done, right? It's a little bit ugly in my case, in my understanding. And what is wrong here is that what happens if you, in this case, it's okay. This first constructor is okay. So it's a parser of a string. So I provide a string, it parses the string, it injects everything. But here in this constructor, look what's happening. So I provide some information, some data for the URI. First, it builds the URI, then it checks it and parses back. It's a little bit weird, right? I'm not sure why it's done like that, and it's always the same. Look, another constructor. Again, they build the string, then they check something, and then they parse it back. So when you provide these attributes, they don't go directly into private attributes of the class. They go through this quite weird schema of printing and then parsing. That's happening, I think, because they allowed the code inside the constructor. That's what I mentioned in the beginning. So we should not allow this code, this parsing, to happen inside the constructor. So the constructor should be codeless. When you build an object, it doesn't need to parse anything. It just has to say, yes, I'm ready. I got what you give me. I have everything, and now try to use me. When you start using me, I'm going to throw an exception if it's not a valid URI, if it's something wrong. So how will we do that? How can we fix that? Because we need to parse, right? And we also don't want to create the parser. We can actually move, this is the first approach, we can take this class parser and we can move it outside of URI. So we will have URI and URI parser. So you will create the parser, you will give some data into the parser and say parser. It will parse it for you, return the URI, and here you go, you have the URI, you do whatever you want. But in that case, I don't know why they didn't make that, even though they have no problem with parser. But I'm saying that in general, probably you've heard that classes which have names ended with ER, like parser, controller, manager, encoder, decoder, all of these names are wrong. So if you have an object which you have a class which is named like that, which ends with ER, then your design is wrong in general. So you're doing something wrong. So the name of the class has to be table, chair, computer, well, computer, I don't know, book, client, employee, URI, URL, file. That's a good. These are good names for your classes. Why it's a mistake? Because the idea is that if your class is named like controller or manager or something with the ER, it means that you are building a machine that just does certain procedures for you, certain operations. But you don't build something which is an entity for you. So there are two different things: it does for you or is for you. So it is a table or it does some table-related operations. It is a book or it's a book parser or it's something that does operations for the book. So it's kind of conceptual thing. It's of course technically will work. Technically the book parser will work and URI parser will work as well. But if you make that classes, you will think more and more in terms of procedures just attached to data instead of really objects, which are objects. So names have to be nouns all the time. Nouns, существительные. So
This more efficient name for you, like instead of parser.
Instead of parser, that's a good name. So let me show you how I would do that without using the name parser. I would say, so this is how would they do it. They would say new parser parse, maybe this one, right? This is how we can do that with the parser. Instead of that, this is how I would do it. I would create another class, which I would call, for example, like this. String, which behaves as a URI. And I would declare it like this. So I create a class which encapsulates the string, and it is a URI. When you start touching it, and you're saying here, then I do parse, and for example, return, I don't know, parse. Maybe I'm just making this up. I'm kidding, but you get the idea. So instead of building a parser, which will parse when I ask it to parse, instead I create a class which is a URI already. And when you start touching me, so here's my constructor. When you give me the string, I just encapsulate it. That's all. I'm not saying anything. It's good or bad. Maybe it's not a URI at all. Maybe it's like the test. Whatever, I don't know. Maybe it's wrong. I just encapsulate it. When you ask me for the scheme or whatever, get query or get host, there's no host. Okay, I can't get it. And then here I'm going to throw an exception. If it's not a good URI, that will be a good design. And then I have string as URI, and then I have new URL as URI, for example. And then I have new, I don't know, I can have many other classes which will convert something to the URI. Not convert, I'm not converting anything, I'm not parsing anything. So the user doesn't see the parsing. The user doesn't say parse, doesn't say convert. The user just has the string. It just has the URI. That's my point. That's how I think object-oriented programming should be. It's going to parse again and again. That's right. It's a good question. If you don't want to parse again and again, then you say, you can catch it, for example. You have to say, this one is final, and this one is not going to be final. You have host, and then you say, if, I don't know, this host is no. It's really primitive. It's not perfect because Java is not perfect. But ideally, Java would think about that correctly, not create these JDKs with this trash code. But instead, Java would give us something like this internally. So Java would say, here's your compile time or runtime annotation once, and that means that it's going to be executed only once, and that's it. If Java would give us that, we have everything solved, right? But now we don't have this in Java, so we need to introduce some other mechanisms to catch it and to store the results of parsing, because obviously we don't want to parse it again and again. Or we can do it differently. We can even do it like this. That's even better. So if, let's say, you have this class, and then you say, I don't want to parse it again and again, but I don't want to combine two paradigms. Okay, I'm going to create another class, which will be called class URI just once, which will also implement URI, and I'm going to use it like this. New URI. Okay, people are leaving on this note. Just once. There you go. So if you, and this class will catch everything. You get it, right? So this class will, if you call get host, it will host it, it will catch it, it will catch everything. So it will guarantee that it's going to be called only once. So it will say, if I have it already, return it only once. So if you want the string as URI, which parses again and again every time, then use this class. If you wanted to catch it, use that one. What?
If something equals to null,
yeah, exactly.
So, but you told
but null is better. Yeah, that's what I said. That this is why this is Java. Come on. Sometimes there's no choice. There's no choice to do it the other way around, unfortunately. So, well, you can actually introduce. Well, you can do it without null. You can create some class. I don't know. You can do it private. Yeah, optional, for example, here. And then not optional, but atomic string, something like that. Atomic ref. Yes, so you reference. So you can do something in Java, and then say host, and then say if host this host something contains. I don't know how it works there, but you can invent some caching. But ideally, of course, Java would give us this annotation or some feature for the compiler, and then the whole problem is solved. Then we will have this really beautiful object-oriented design.
What about the factory approach? For the factory with two methods like parse, not parse, from string and from basic.
Yeah, it's still not good. I in general don't think that factory is a good idea. So factories are not really what we need to have. So I really like the new operator instead of factory. But yeah, of course you can create it like this, and then from string. But what's the point if inside this method you will still have something like that? Something like that will happen. So what is the point of creating these factories? I mean, I think in general, factory is a bad idea, in general, generally speaking. We already have the feature of new in the language. So these factories, they were introduced to solve the problem of two complex classes. So we have two big classes, too many constructors. We don't know how to create an object from constructor number 5 or constructor number 7. So let's create 15 methods. From name, from title, from. It's just too big. The classes are too big, and the factories are not solving the problem but hiding the problem. So instead, we need to simplify and make classes smaller in general. I think we have to finish, but we may have some questions, right? Which are welcome. Questions are welcome. Yes.
Previously, you said that you got to use fast-fail approach.
Yes.
But in this case, you don't use it because you have incorrect state.
Yeah, that's a question we discussed already. So you're saying that here I'm encapsulating the string, which may be a wrong string, right? Which may be not a correct URI, and I'm still encapsulating, and the class will still be alive. So the class will, let's say here, I encapsulate this test, and it's still a good class, and then a good object, and then I use it somewhere, and then nothing happens. I think that this is a good approach, that the object should not fail, should not do anything until somebody actually gives control to that URI. So if I'm saying URI to string here, then yes, that's going to be the exception. So exception will happen here. But if I don't say, for example, I have return here like this. So this code will never happen. So what's the point of throwing an exception on this line? What's the point of validating, of parsing, of testing, of doing anything? We should not touch, we should not take control, we should not start working on anything until they give us the control explicitly. I think so. I believe so. So we definitely have to fail as fast as we can. But in this case, an object should not have an option to fail. It should not have time to fail because it's still in the first phase. It's still in the creation phase, and instantiation phase. It's not working yet. It's just preparing to work. We're just bored. We're just making it.
So you don't have any object invariant after construction.
After construction.
Construction it is not invariant. Right?
It may be in wrong state after construction. Of course, it may be. Some of them, well, not wrong state. If it managed to encapsulate everything, that's a good state. So now the behavior is broken. So the state is okay, but behavior is broken.
So, the test is not actually the URI. So it is not URI.
It's not, but in order to understand that, we need to use the behavior.
You just created URI, which is actually not URI. Right.
But only the URI knows about it.
Okay.
only it knows about it, and it will tell us about it only when we ask. So, because let's put it this way. Okay, I'll give you another example. Let's say we are creating the URI from. Let's do it this way. What do you think about that? So I'm creating the URI, and I am giving, of course in Java it's not going to work because string is not an interface, but let's forget that for a second. Let's say we're doing this. So I want to get the content of this file. I make a file input stream, then I make input stream as a string. So if you check here, it's going to return what's in the file, which is going to be the test, which is going to be the wrong URI. Okay, if you call toString, and then I'm saying new string as URI. So I build that construct. I build it, and then I'm saying return 1. So the structure is, I don't know, do you know it's a valid URI now or not? In order to check it, you need to say, give me the content of the file. So start working with the file. Read the file, return me the text in the file, let me parse it, and then I will break. We shouldn't do that. It's a valid state for the object. This object, perfect valid state, because it perfectly encapsulates what it needs. It encapsulates the source of data. What's in the source of data? It doesn't know. It doesn't want to know. It will want to know only when it's going to be the time to get this string. So the state, I'm answering the question, the state of the object is good, is valid. Because the object doesn't know what's in the string. It doesn't know what's in this URI. It's not the moment to know. It's too early to know. You see? But we're just assuming that, okay, if the constructor of something is coming, we just need to know what's there. Our state is not the content of the file. Our state is just the link to the file. So here, my state of this thing is the link to that thing. And then the state of that thing is a link to that one. And then the state of that one is a link to the file. And then the state of the file is this text. The content in the file is a behavior. It's not a state. So the state is an object, state. But the content which will fly from the file to me, it will be the behavior, which will jump from the file to me to higher level, and then to me to my toString. And then I will throw an exception because look, hey, the behavior is wrong. I mean, something wrong is coming into me, so I cannot parse it. I throw an exception. So state is state, behavior is behavior. Two different things. State is not the text. State, well, in this case, the state is more like a link to what's the to the string. Does it make sense? Just think about it. I mean, probably it's kind of opposite to what you were doing before, but try to look at this from a different perspective. I think we have to finish, right? No, we have time. Yes. Yeah. We're gonna dance.
Yeah. If you have more questions,
Yeah,
you can
I
ask
was
us.
about set. I think that is not a bad idea if your example, you must check some inputs when you create the object. So if you just expose some fields in our space without checking, maybe
you shouldn't expose any fields. You shouldn't expose any attributes. So nobody should be able to set anything. So that's just wrong. So if you allow people to set something inside you, then
we compose set approach with immutability because we may, for example, create a new object inside the set and return it. Maybe it makes sense to not set, but change private setters. Something like that.
no, I think in general we need immutable objects, and more, like in all situations, like the file, for example, or URI. You cannot set anything there. You can only get.
Well, for example,
Yeah, here you can set.
For example, you want to change his name, so you can be set name and inside the set, you can, for example, create a new class with a new name and return it.
Yeah, but in this case, don't call it a setter, call it rename. So don't use the prefix set, because this get set in Java, they must mean setters and getters, traditional setters and getters, which change something in the object. Easy to find the function in IntelliJ. You click dot set and then you see. Well, yeah, of course, if the class is huge, if the class is big and you have like this amount of methods, then yes, of course, you want to set because you're used to the name set, you know how it looks. But don't create so big classes. If you create classes which have more than 5 methods, then something is wrong. So 5 maybe, I don't know, 5 is a big number already. So it have to be like 2, 3 methods, 2, 3, 4. And in that case, it will be all easy. You will understand what they do. If it's rename, it's rename. If it's, call, it's call. Yes, it can make a project. It can make an object mutable, or it can make it still keep it immutable and return the new object. So it depends on how you design it. You can, for example, it's a long story about immutability because immutability is a more complex subject than we just think. So we think it's either mutable or immutable. In reality, it's more complex. I can show you just a few words in 1 minute. So look at this class file. And look at the method set executable. So it does change the status of the file, right? It goes to the disk and it makes the file executable. But it's not a setter, the file is still immutable. Or for example, the method delete. I delete a file, look. I delete it on the disk. But the class is still immutable. Look at the description of the class. Let's scroll. Where? Yeah, instances of the file class are immutable. That is, once created, the abstract path name represented by a file object will never change. So the state doesn't change. So my state is the name of the file on disk. My behavior, delete the file, change the status of the file, remove the file, rename the file, not rename, but remove the file, all that manipulations, they can happen, but I'm still immutable. So immutability is not black and white. It's many, many different, in between. It's not like, yes, this is immutable, like class string, and this is mutable, like class label from AWT. No, there are many, many other options in between.
Yeah, if you have more questions, you can ask in Russian, by the way, I think.
Of course, but I'll have to turn off the camera. Let's see, maybe some people have some questions for us online. Keep up the great work. Okay, it's not a question actually. We are finishing. Thanks.
Хорошо, ребята, я перейду тогда на русский. Если нет вопросов, Егору, можете, если будут у вас вопросы там лично, можете подойти пообщаться.
Thank you guys. You're saying stuff.